So we now start looking at integration. So where we are now, missing a class is very, very dangerous because you may miss two topics. So methods of integration. The first method is extended power rule. Extended power rule. Extended power rule. Under differentiation, we used to do this. If you have y is equal to x to the power n, and they ask you to differentiate y, we are dropping n and then subtract a 1 from it. Now, integration is the reverse of this action. So when they say integrate, they mean go back to the original question, moving from the derivative. So if they ask us to go back, they'll be asking us to integrate dy with respect to x. On the right, the same thing will happen. They'll be asking us to do the reverse with respect to x. Okay, so on the left, we'll remain with dy. We'll remain with y when we integrate. In fact, the right notation is this one. You multiply dy, you multiply throughout by x, by dx, and then integrate now. So it's okay. So integrate. Then the integral of dy is y. The integral of this guy, to go back, for us to remain with x to the power n, this n must be out of this position. So what then do we do? Extended power rule says, let's see, since we have n minus 1, what if we add the 1 there and divide by the very thing down here? Let's see if we'll get the question. This is going to be n x. Negative 1 plus 1 is 0, so we remain with n. Same thing will remain down. We can add a constant. We can add the constant so that here we get x to the power n now plus c. What is the c for? If we had y is equal to xn plus 3, the derivative of y will be nx n minus 1 plus 0, because the derivative of any constant is 0. This would still come out if we had x power n plus 100. To differentiate, you get n x n minus 1 plus 0. So that's why there will be a constant when you integrate, taking into account the possibility of having a constant added to x power n. Whatever I was doing here, if it's confusing, forget about it and pick this one. Extended power rule. To integrate xn dx, you have xn plus 1 over n plus 1 plus c. This is the formula. Examples for best consumption. examples.
I'm kindly asking for the previous slide. Okay, thank you.
So 1, integrate A, the integral of x power 5 dx. This is going to be x 5 plus 1 over 5 plus 1 plus c, which is x power 6 over 6 plus c. That's simple. B, the integral of 8x power 3 plus 3 over root x plus 5 dx. This is going to be the integral of you can also write this one, will maintain it, but here we'll write it as 3x to the power negative half and keep the 5. This is because we understand that 1 over x is the same as x to the power negative 1. And we also understand that root x is the same as x to the power half. So combining these two, if we have 1 over root x is the same as we have 1 over x to the power half. But because it's in the denominator, it will be raised up the negative half.
Utupenda kufanya ngomba kada Manuel TV.
So that's the case, and then we integrate. So we have 8 x4. Can be mute. 8x4 over 4. So I've added 1 to 3 and divide by the result. Plus 3x negative half plus 1 is the same as negative 1 plus 2, which is half. So we have half over half plus 5. For x not to appear where there is 5 there, it means that the power of x was 0. Now we are adding a 1 and then divide by the very thing, then we add a constant. So that we get 8 by 4, that is 2. And then plus, if I have 3 over half, it's the same as I have 3 divided by half, which is 3 by 2 over 1, which is 6. So we get 6. X to the power half is the same as the square root of x, and then plus 5x plus c. This becomes the integral using extended power rule, coming direct from some perspective. Otherwise, in this course, we do not we don't have difficult things, you know. As far as integration is concerned, we have maybe questions like this one. I give you another example. Integrate x3 minus x squared over x power 7 dx. In integration so far, we're saying that there's no quotient rule. So break this and write it as x3 over x7 dx minus x squared over x7 dx. So you can separate like this. And then this is the same as x to the power -4 dx minus x to the power -5 dx, so that we get x to the power -3 over -3 minus x to the power -4 over -4 plus c. What are we doing? -4 plus 1, you get -3. -5 plus 1, you get -4. So as we add, they look like they're reducing, but they're increasing. Simplifying this is going to be -x, or we can actually switch them down. So we'll write it as -1 over 3 x to the power 3 plus 1 over 4 x power 4 plus a constant c. So we have brought them back as positives. How did the -4s come about? From exponential, we said a to the power m over a to the power n is the same as a m minus n. And so that's what we are using there. Okay, this was method 1, substitution. Extended power rule. Now we go to method 2. Second method.
So may I please see the previous board? Thank you.
Substitution method. We said that to integrate x to the power n dx, we just say x n plus 1 over n plus 1 plus c. Now suppose we wanted to work with a different letter here. Where there is x there, suppose we say, okay, let where there is x there, we put u. Let u be equal to x. Then we'll also be forced to change the x. So let's see, let's differentiate u with respect to x. What are we getting? We'll get 1. So if we solve for dx, we'll have du is equal to dx. So the switching is going to be, where there is x, we'll put u to the power n. Where there is dx, we have found that dx is equal to du. So we'll put du. Integrating this one using the same rule, we'll have u n plus 1 over n plus 1 plus the constant c. This is what we call this integration by substitution method. And let me show you what it means, because here you can't see properly. Integrate you have 2x over the square root of x squared plus 3 dx. Have you seen that we said there's no quotient rule? Look at this. When we had a fraction, we had to split for us to go to extended power rule. Now we're able to split this thing. It's a no-go area. So you say, okay, suppose we work with what we know. We let this thing in under the root to be u. Let's see if we can differentiate it. We differentiate u with respect to x. We'll get 2x. So if we solve for dx, like we did in this one, we'll have du is equal to 2x dx divided by 2x divided by 2x. So we'll have du over 2x is equal to dx. Then we'll come back here and say, okay, let's substitute. We have 2x over the square root of u. Dx has been found to be du over dx. Sorry, to be du over 2x. So this 2x here can take away the 2x there. So now what we'll have is the integral of u to the power negative half. The u in the root can go up the negative power and then du. It does now look like this one, where we can use extended power rule. We'll say, okay, so if we add the 1 and divide by the result, and then add the c, let's see how far we go. Negative half plus 1 is positive half over positive half plus c. This is the same as 2 the square root of u plus c. Now what is u? U is x squared plus 3 and then plus c. So this thing becomes the derivative, I mean the integral.
Sir, can you please explain again on starting from there where you made it look like the formula where there's u?
From here.
Yes.
So here, when you start integrating, you're just adding a 1 to the power and divide by what you get.
Oh, so how did the negative 1 over 2 the power?
How did it come about? Whenever you have this, the first thing you notice is that being told that there's a root, square root, is the same as having that thing to the power half. And then now it being in the denominator, it attracts a negative if you take it out. So whenever you see the square root, it's the same as you have seen power half. Whenever you see the cube root, it's the same as you have seen power 3 over 2. Power 1 over 3. Power 1 over 3. That's a cube root. Another example.
All right.
Okay.
So I'm kindly asking if you can re-explain from the first part. I'm lost.
Okay. So because you cannot use any other method here, so far we already know extended power rule and substitution. So extended power rule cannot work in this case. So you try to simplify your question. Say, okay, so this is what you do. Whenever I ask to integrate, you check what's the difference between the powers of x of the thing inside the brackets or inside the root and the power of x which is outside the root. If the difference is 1, then you can use substitution. So here we have x squared plus 3. On top, we have 2x. The difference between the powers of x here is 1. So because the difference is 1, we can use substitution. So we'll let this one with a higher power be u. So that when we differentiate it, we have the power of what is on top. And then from here, we solve for dx. So you cross multiply, you have du is equal to 2x dx. Then divide by 2x, divide by 2x, so that you get that dx is equal to du over 2x. Then now, where there's dx there, you substitute du over 2x, du over 2x. Where there's x squared plus 3, you substitute, you said it's u, so you substitute u. And then leave the 2x on top where it is there. It will be taken care of by the 2x under du. So it will cancel there. And then now you remain with 1 over. From there, you're remaining with the integral of 1 over root of u du. But the over root can be taken up, but the root is power half, so you can write it as negative power half. And then now we are back to extended power rule, where you add the 1 and divide by what you get. Then add the constant. Then you get to this. Then go back. Remember, you said u is x squared plus 3. You can't leave your answer in this form. So substitute back what u is. Another example. Example 2. The integral of x over the square root of x squared minus 9 dx. Again here, we cannot split the denominator. So we'll let, and as you can see, the difference between the powers of x, or what is under the root and outside the root, the difference in powers is 1. So you let u to be x squared minus 9, and then differentiate it. So you get 2x dx. Then divide by 2x, divide by 2x. So then we'll have du over 2x is equal to dx. And then say, okay, then this can be written as x over the square root of u du over 2x. So this x and this x will cancel. So now we are going to have the integral of 1 over root u du over 2. So this 2 can be taken outside the integral, because it's just a constant. Then the 1 over root u can be written as u to the power negative half. And then du. Then integrate it, so you have this guy, u power negative half plus 1 over negative half plus 1 plus the constant c, giving us 1 over 2 u power half over half plus c. So this half and this half will cancel. So we remain with u power half plus c, which is the root of u. But what is u? U is x squared minus 9. And then we add a c. Now, because we know that the derivative of sin x is equal to cos x. We can as well integrate, find the integral of cos x to just be sin x plus c. Do the reverse. Find the integral of sec squared x dx. Since the derivative of tan is sec squared x, the integral of sec squared x is going to be tan x plus c. So to find the integral, you are looking for a function whose derivative is what you're integrating. So that if there's a question of this form, integrate sine 3x cos x dx. Because we are seeing the derivative of sine here, then we can say let u be equal to sine x. Its derivative is going to be cos x dx. So you can substitute here where there's sine, you take u, so you have u3 du. So we get u4 over 4 plus c. But u is sine, so we have sine 4x over 4 plus c. Like that.
What happened?
Hello?
Yes, what happens to the cos x dx?
It is equal to du. So it will be represented by du. So you are changing variable. So you are used to solving for dx, so you solve for dx. So dx is going to be du over cos x. And then go back to your integral and have u power 3 cos x du over cos x. So you see that cos x will cancel cos x. So you go back to u3 du, which you integrate now in this form.
I can't understand what was happening on the second last step.
Second last here.
Yes.
After you integrate, you get u power. The integration of u power 3. The integral of this. Use extended power rule. So you add a 1 to 3 and divide by the same thing and add the constant, which will be u4 over 4 plus c, which is what we have here. Yeah.
Oh, okay.
Then what is u? U is sine x. So you come and substitute sine is to the power of 4. So sine 4x over 4 plus c becomes the integral. Okay. So another example.
Wait, now wait.
I think you're going to take a screenshot.
All right, proceed.
The integral, find the following. The integral of e 3x dx. The integral of this integral of sec squared is what is done, and not integral of sec. This is not that. Okay. So the integral of e 3x dx is going to be 1 over 3 e 3x plus c. Why? Because when we differentiate, we differentiate 3x. If we differentiate this one now, let's say we are differentiating, we're going to have 1 over 3 multiplied by 3, and then e 3x plus 0. So the 3 will cancel at 3, so we remain with e 3x, which is the question there. Now, since to integrate is to reverse, that is what we'll be doing. So I bring it in a nice way now. So we'll start with the general. E, A, or we say E, G prime of X, dx. Remember, you will never divide a variable. The only thing that can go down is a constant. So this is going to be 1 over G prime of X, E, G of X plus C, provided that G prime is a constant. So if we have 2e 4x plus 1 dx, this is going to be 2e 4x plus 1 over the derivative of 4x plus 1 is 4, and then plus c. Simplified to e 4x plus 1 over 2 plus c. C, the integral of 2 to the power 3x dx. Remember, the derivative of this guy, the derivative of such a structure, 2 to the power 3x, was coming out to be what? It was coming out to be 2 to the power 3x, 3 into. So the integral will have 1 over 3 into 3 multiplied by 2 3x plus c. So what comes out of the derivative, this constant here, in the integral, it goes in the denominator. So I'm saying if you are integrating 5 to the power 4x plus 1 dx, the integral here is going to be 1 over 4 ln 5 4x plus 1. Instead of it multiplying, it will be dividing. E, the integral of okay, the other things I'll bring them in the next video. So here, let me just put another simple question. 7. If I put x squared plus 1 dx, this is not 1 over 2x ln 7. You never divide the variable. So such an integral should not be treated in this manner. Okay? If that must be the case, then you will see what to do in the next video. Okay, so you quickly log out and log back so that you see what is there. Let's be quick. We're coming to finish integration now.